Bismillahirrahmanirrahim. Assalamu alaikum, everyone. So today I have to present my presentation on the topic that is brain tumor segmentation based on a hybrid clustering technique. So, Sir Dr. Sajid Khan has assigned me a three paper based on segmentation. So in this presentation, I will present on this paper. I will define all these things in our presentation. These are the agenda. So I have to present abstract problem statement, objective, introduction, proposed methodologies, results, conclusion. So what is the main objective of this one? What is the abstract? So all these things we will discuss. So first is abstract. So basically image segmentation is the process of partitioning image into mutual exclusive region. So as we all are familiar with the image segmentation, that in the image segmentation we divide the image into different segments in order to get a good results. So image segmentation plays a vital role in the medical medical image diagnosis. So despite this, image segmentation is still challenging problem in order to get a good image without image noise, non-uniform texture, and the other factors. So basically, this paper presents an image segmentation approach using k-means clustering and integrated with the fuzzy c-means clustering, means by hybrid clustering. So these techniques, so means hybrid clustering techniques, gives a good performance, accuracy, and the computational time is very good. So here you can see that, suppose we have a image that contains a brain tumor, and we have to detect the brain tumor by using our proposed technique. Also, we will compare with the different techniques, just like k-means, fuzzy, c-means clustering, and with combined hybrid clustering, and all these things we will see later in my presentation. Okay, then what is the problem statement? Problem statement is that medical image segmentation plays an important role in clinical diagnosis. I already told you, and then it can be considered a difficult problem. Why? Because commonly medical image have poor contrast, different type of noises, missing diffusive boundaries. So it will be very difficult to detect brain tumors or tumor by the image. So what is the objective of this paper? Objective of this paper is to propose a technique that gave you a good result, good performance, good accuracy, good processing time. So that is all about the paper. So now we are going towards the introduction. What is the introduction? Image segmentation. I already told you that image segmentation is the basically process of partitioning or dividing the image into the segments in order to get the good results. Objective of image segmentation is to change the representation of an image to be more meaningful and easier to analyze. Okay, when we will segment our image into different parts, it will be very easier for us to detect a particular image, particular segment of image. So where image segmentation is used, it is used for object recognition. So you will be given the one image, and in one image you have to detect or recognize the object. Okay, image compression, we all are familiar in the compression means we have to suppress the image. Okay, and image editing, we can edit the image. How we will can edit the image? Because our image will be divided into different segments and we can edit a segment. The result of image segmentation occurs is a set of regions that collectively covers the entire image. So when we will divide our image into different segments, it collectively give the entire image. Okay, then here I will tell you somehow about the brain tumor. Tumor basically, tumor is a dangerous diseases that causes the death. So it is evidence that the chance of the survival will be very low if the tumor is not detected at the early stages. In most cases, the physician gave the medicines on the basis of their strokes rather than the treatment of the tumors, because they did not able to detect the brain tumors. That's why they are treating the patient based on the uh, strokes. So therefore the detection of tumor is essential for the treatment. So it is clear that the detection of tumor is very important, otherwise the patient will not survive more. Okay, then we are moving towards here. There is a need of for an efficient medical image segmentation with some preferred properties such as a minimum user interaction, fast computation, accurate and the robust segmentation results. So these are the need for image segmentation. These are the requirement for the image segmentation. On the other hand, image segmentation algorithm based on one of two fundamental properties of image intensity value, discontinuity and similarity. So basically image segmentation are based on two properties. One is the image intensity values, another is discontinuity and the similarity. In the formal category, segmentation approach based on partitioning image process based on change intensity and the as a edge and the corners. Second one is the image segmentation based on the partitioning an image into regions that are similar due to a set of predefined criteria. Okay, here you can see one image. Okay, so these are the different techniques. MRI technique and the CT scan techniques are used for medical diagnosis. So MRI technique is the best as compared to the CT scan, because MRI does not leave the or leave the race, so that will harm the patient. So that's why MRI is the best technique. So there are also other techniques, segmentation technique, just like as histogram based method, age based methods, AR neural network, and segmentation and clustering methods, just like as k-means clustering, mean shift clustering, mean shift, and fuzzy c-means clustering. So here you can see the one image that contains the result of MRI image and the CT scan. This is the MRI scan result, and here is the CT scan result. So author has proposed the technique that is known as the hybrid clustering, in which we will combine a k-means clustering and the fuzzy c-means clustering. How these techniques work, we will discuss later. So author has proposed this technique in order to get a good performance, accuracy, and processing time. These two methods shows two types of clustering, either by partitioning or grouping. Clustering can be performed by using the partitioning or the grouping. In the partitioning, whole image will be divided into partitions, different segments according to some correct criteria. Whereas in the grouping, the pixels are collected on the basis of the group. Okay, then here you can see the how k-means work. For suppose we have different type of data sets and we have to make the clusters, and we have to decide which data set will be which data set will come in which cluster. For suppose here you can see the k-means cluster, k the value of the k is 3. Here we have made the 3 clusters. Okay, how the k-means cluster will give the result in the image segmentation. This is the result of k-means clustering in the image segmentation. Then we have a fuzzy c-means clustering. In the fuzzy c-means clustering, we also make the cluster, but in this, one data set can be part of more than one clusters. So how it will give the result in the image segmentation? Here you can see the result of fuzzy c-means clustering in the image segmentation. So how purpose technique will work? Basically, our purpose technique is divided into 4 stages: pre-processing, clustering, extraction, and validation. So what will happen in the pre-processing? Basically, MR image will be given. Then we will apply median filter in order to remove the noise. Then skull removal. Okay, the skull will be removed from the image, and then we will apply the clustering, either K-means clustering, fuzzy C-means clustering. Author has proposed the hybrid clustering, so we have to use the hybrid clustering, means combination of K-means clustering, fuzzy C-means clustering. And then we will extract the image that contains the tumor cluster by using the thresholding. And also we will filter with the median filter, and then we will get the level of the tumor level set. We will apply the level set function. So what will do level set function? Level set function basically is used based on the numerical analysis, and it will automatically create a shapes. On the basis of shapes, we will create a we will detect a tumor, and then we will validate it is either it is correct or not correct. Then this is the pseudocode of the hybrid clustering, the proposed technique. First, it will take the image, then it will apply the median filter, then it will save the thresholding image, then call set. It will call the level set function. I already told you what will do level set function. Then save the resulting image. What we have gotten the result, we will save, and then display the segmentation image with the continued tumor regions. Then we will calculate the total pixel. Then we will calculate the n white, black pixels, and also we will calculate the ratio or the area of the brain tumor. And here is the experimental result. Basically, author is check out the result on the basis of three data set. That first one is the data imaging and the communication in medicine, that will contains the 22 images of the brain tumors. And second, we have data set that is the brain web data, that will contains brain web data. It means it will contains the simulated brain tumors, brain MRI. Third one is the Braid's database from the multimodal brain tumor segmentation. So here you can see the result. We have three different data set, and we have image, original image, and we have removed the skull removed. Basically it is already removed in first data set, and the second data set is already removed. Okay, here you can see the by applying the median filter, we all are familiar. By applying median filter, we can remove the noise, and by applying the k-mean clustering, we have see that this result. Applying threshold, okay, and by level set function, and we have get the truth normal results, either true false or positive, true false or true negative. Okay, then we have the result. This is the area of the tumor that contains the one image. One image contains this tumor. And then we have compared the different techniques. Here is the k-mean clustering, and the EM, and the MS, mean shift clustering. So here you can see the K, the value of the K, and the processing time. Okay, so this is the comparison of different techniques, and these are the results of different techniques. Okay, here is the comparison of FCM, fuzzy C-means clustering, and the K-means clustering. So basically, fuzzy C-means clustering takes more time, and K-means clustering takes less time. It will fuzzy C-mean clustering will give you the accurate results, and K-means will not give accurate result as compared to the fuzzy C-means clustering. And here is the result of tumor detection by KF, means hybrid clustering. So this is the hybrid clustering result. So here you can see the iteration number of iteration and the time taken by the fuzzy C-mean hybrid clustering. And then we have the performance. Here you can see we have three type of data set: true false, true negative, false negative, false negative. And here we have the accuracy, and here we have accuracy also, expectation maximization. So it was the expectation, and we have gotten this result. This is the performance that are represented in the form of chart. And finally, we are concluding our presentation, concluding my presentation. MRI and CT scan are used for medical image diagnosis. MRI is most comfortable as compared to the CT scan. I already told you that MRI will not release the rays, and K-mean clustering it takes less time in order to process the data, and C-mean clustering will take more time. C-mean clustering will give you the accurate result, can predict the tumor cells accurately. And fuzzy Seaman algorithm fails to segment image corrupted by noise. If the image contains the noise, the fuzzy Seaman clustering will not be able to detect the tumor. So that's why author has proposed the collectively a hybrid clustering that will contains the k-means. It will take less time, and fuzzy C-means it will give you the good result. So that's all about my presentation. Thank you.